Hello viewers, I am Kausalya. Today we are going to solve problem number 1 under the category steady state error by second method. For a unity feedback control system, the open loop transfer function is g of s is equal to some function is given. Find the steady state error when the input value is given here. Right. So we are asked to find the steady state error and the type of feedback is given as unity feedback system. Right. So we are using the formula E of S. So E of S is equal to R of S divided by 1 plus G of S into H of S. Right. So the value of R of S is given here and the value of G of S is given here. Since the type of feedback is unity feedback, the value of H of S is found to be 1. Right. So we are going to substitute the values here. So when you substitute the values, you see we are having an expression like this. This is our R of S expression, 1 plus this is our G of S expression and this is our H of S. Right. The next step is we are going to take LCM for the denominator part. So when you take LCM, what happens? Here, this s square into s plus 1 get multiplied with the 1 here. So, s square into s plus 1 plus 10 into s plus 2 divided by s square into s plus 1. Right. So, the next step is I am moving this denominator term to the numerator part. Right. Here the numerator has 3 terms. Right. 3 by s minus 2 by s square and plus 1 by 3s cube. Now I am going to shift this denominator part to the numerator. What happens? When you move a denominator term to the numerator, you have to take the reciprocal. So here 3 by s, right, I am moving this term to the numerator part. So the reciprocal of it comes here. So s square into s plus 1 divided by s square into s plus 1 plus 10 into s plus 2. It is here. Right. And the next term is minus 2 by s square. So right here minus 2 by s square. Again this reciprocal term, when you take this denominator term, you will get the reciprocal when it moves to the numerator. So again here I am having the term like this. Right. And the next thing I am having the third term plus 1 by 3s cube. So again writing the term and again moving this denominator term to the numerator part. Right. Hope you people clear with this step. Then the next thing is, we all know the formula. The steady state error is given by limit t tends to infinity e of t. And this formula is again, we can write this steady state error as limit s tends to 0 s into e of s. Right. Now we have our e of s here. So just we can substitute this e of s term in this formula and finally we can find the value of steady state error. Right. So here in this formula, we are going to substitute the value of e of s. So here you see limit s into, I had substituted the value of e of s which we had find out in the previous step. Right, just I had substituted here, nothing more than that. The next step is I am moving the s which is present outside here. You see, I am moving this s term inside this bracket. So this s is common for all the 3 terms. So this s when moved inside will get multiplied by all these 3 terms. Right. So that is the step I had written here. So s into 3 by s, the remaining terms as such, and again minus s into 2 by s square, and here again plus s into 1 by 3s cube. Right. So here I am again cancelling the common terms. Here these two s term cancel each other, and here this s square term and this s square term cancels each other. And here you see I am having 3s cube. So here I am having a square term. So this square and this square will cancel each other. And finally I am having a single s term, and that s term and this s will cancel each other. So finally here I am having this derivation as, so this is our part of the expression after cancelling the common s terms. Right. So here I am having this term, and here this is our second term and this is our third term. After cancelling, you see here this s and s cancel each other, so the first term will get reduced as 3 into, we will be having this term, right? So that is the expression I had written here. Similarly for your second term and as well as for your third term, right? So after writing this expression, our next step is we have to substitute the value of s as 0 here, right? So here when you substitute the value of s equal to 0, what happens? Here this term is 0. So 0 multiplied by any term is again 0, and again 0 divided by any term is finally 0. So this first expression entirely reduces to 0, right? So that is the thing I had written here. The first expression reduces to 0 here, right? So the next thing is, consider our second expression. When you substitute s equal to 0, here I am having an s, right? So 0 multiplied by anything becomes again 0. So our second term also reduces to 0 here, right? And the next thing is third term. So for this third term, when you apply limit s tends to 0, that is what happens, 0 plus 1 divided by, so when you substitute s as 0, 0 multiplied by anything, again this entire term reduces to 0 here. And the next thing is 10 into, again here s becomes 0, so 10 into 0 plus 2. So when you solve this, finally we will be having an expression as 0, okay, these two terms are 0, so 1 by 3 into 0 plus 1 becomes 1 divided by, here 0 plus 2 is again 2. So 10 into 2 is 20, 20 plus 0 is again 20. So I will be having an expression like this. So when you multiply these two terms, finally I am having 1 by 60 as answer. So therefore, steady state error for the given problem is given as 1 by 60. This is the second method of solving the same problem. Hope you people understand. Thank you.